In this video, we are going to start with Mathematics Chapter 23, Trigonometrical Ratios of Standard Angles. In the last chapter, we studied about the relationships between the sides of a right angle triangle and the 6 different trigonometrical ratios whose formulae we remembered or memorized by the mnemonic SOHCAHTOA. So, ka, toa. And I told you that if you want to use the terminology involving PBP, HHB, then it is your own choice. You can do that. But I also explained how SOHCAHTOA is much more practical and you will make less mistakes if you use the terminology of opposite, adjacent and hypotenuse. So in this chapter, we are going to take our knowledge of trigonometry ahead by finding the values of trigonometric ratios of some standard angles. So if in a right angle triangle, the acute angle is, let's say, 30 degree or 60 degree or 45 degree for that matter, we can find the values of sine, cos, tan, cot, sec and cosec of these standard angles. So we are going to find their values by some derivation, and we are going to prepare a table of the values of values of trigonometric ratios of some standard angles, and then we are going to use those values in numericals. So let's first start with the derivation part, that is the values of trigonometrical ratios of the angles 30 degree and 60 degree. So for finding the values of trigonometric ratios of 30 and 60 degree, you first have to draw an equilateral triangle whose sides are of measure 2a. Each side is of measure 2a, AB, BC and AC. In this equilateral triangle, you have to draw AD perpendicular to BC. You have to drop a perpendicular or an altitude to the opposite side from the vertex. Now this perpendicular is also a median. So that's a property of equilateral and isosceles triangle, that an altitude is also a median. So if AD is also a median, it will divide BC into two equal parts, and hence we can see that BD equals DC. And as BC is 2A, BD and DC will be equal to A each. Okay, so BD is A and DC is also A. Right? Now, if we consider triangle ABD, which is a right angle triangle, since if we want to apply trigonometry, we know that a right angle triangle is must. Right? Without right angle triangle, we cannot apply trigonometry. So, in right angle triangle ABD, if we apply Pythagoras theorem, we get AB square is equal to AD square plus BD square, or AD square is equal to AB square minus BD square. That's the Pythagoras theorem. So we know that AB square is 2A the whole square, BD is A, BD square is A the whole square. So 2A the whole square minus A square is 3A square. So AD, which is the length of the perpendicular, is root 3 times A. Right? So you must know this formula from other chapters as well, area and perimeter or something like that, areas of plane figures, that altitude of an equilateral triangle is root 3 by 2 times side. So if you see closely, we get the side which is A, which is half of the in triangle ABC, the side is 2A. So half of 2A is A times root 3. So basically it is root 3 by 2 times 2A. 2 gets cut and we get root 3A as AD. So we got the length of AD. Okay. Now every angle of this triangle ABC is 60 degree. Every angle. So angle B is 60 degree. Right. So what will be angle BAD? Now as we know that angle ADB is 90 degree, angle ABD is 60 degree. So by angle sum property, we can say that angle BAD is 30 degree. So just consider triangle ABD. Okay, don't look at any other triangle. ADC, ABC, no. Don't look at any other triangle. Just consider triangle ABD. So we can find the values of trigonometrical ratios of angle BAD and angle ABD in triangle ABD, which are basically the angles 30 degree and 60 degree. So we can find sine 30, sine 60, cos 30, cos 60, tan 30, tan 60, and so on. We can find all the other trigonometrical ratios. If we know sine, cos, and tan, we can easily get cot, sec, and cosec, because they are the reciprocals of tan, cos, and sine. Okay, so what is sine 60? See, sine 60 is opposite upon hypotenuse. Opposite is root 3a and hypotenuse is 2a. So root 3a by 2a is root 3 by 2. What is sine 30? Sine 30 is again opposite upon hypotenuse. Opposite is a and hypotenuse is 2a. So a by 2a is 1 by 2. Do you see here? Similarly, we can find cos 60, cos 30, tan 60, tan 30. And if we know these, we can easily find all the values of the other remaining trigonometric ratios, that is basically cot, sec, and cosec 30, cot, sec, and cosec 60. We can find their values as well. So we have derived, or we have found out with the help of this method, we have found out the values of the trigonometrical ratios 30 degree and 60 degrees. Okay, so similarly, if you consider a right isosceles triangle, right isosceles triangle is a triangle in which one of the angle is 90 degree and other two sides are equal. That means the other two angles will also be equal to 45 degree each. And if we take the equal sides as a units, then the hypotenuse by Pythagoras theorem will become root 2 times a. And in this triangle, you can find the value of sine 45, cos 45, and tan 45, which comes out to be 1 by root 2, 1 by root 2, and 1 if you apply trigonometry, because you know that this angle is 45, this angle is 45. You can easily, this is 90, so you know the length of each side. So you can easily find the values of sine 45, cos 45, and tan 45. And if you find sine, cos, and tan, cot, sec, and cosec is not difficult to find, right? Also, you must remember that sine 0 is 0 degree. Sorry, sine 0 degree is 0, cos 0 degree is 1, sine 90 is 1, and cos 90 is 0. So when I'm going to draw the table for you and explain you how to fill the whole table and how to memorize it, because in your exam you need to draw the table beforehand. Before you start writing your paper, you need to draw the table and write all the formulae for trigonometrical ratios and everything before you start writing the paper, so that this reference is available to you, right? So this is basically the table which we are going to draw. So I'm not going to show you this table. I'm not going to show you this table. I'm just directly going to go and make this table for you. Let's do that. Okay, so let's draw the table. So this is the table of values of T ratios or trigonometric ratios of standard angles. Table for values of trigonometric ratios of standard angles. So in this table, what you're going to do is you're going to write angles over here, and you're going to write T ratios over here. So the first T ratio is sine, right? Sine theta, and the theta will be over here. First is 0 degree, then there is 30 degree, then there is 45 degree, then there is 60 degree, then there is 90 degree. Sine theta, cos theta, tan theta, cot theta, sec theta, cosec theta. These are all the T ratios, trigonometrical ratios. and over here you have all the standard angles. So please note the technique of making this table. I'm sharing you this very, you can say, important technique with all of you, which will be utilized in examination, which will be helpful to you in your examination, because in your exams you won't be given these values. You have to memorize these values. Okay, so that's, there you go. This is your table ready. Okay, so what you need to do is you need to remember the first row. The first row being the row of sine theta, the values of sine of these standard angles. You must remember. So the only thing you will memorize is this particular row. This is what I'm talking about. You will memorize this. You will memorize this. The values of sine of some standard angles. And the other part of the table will be filled by us using some techniques which I'm going to share with you. So remember that sine of 0 degree, sine 0 is 0. Sine 30 is 1 by 2. As we found out in that triangle, 30, 60, 90 triangle, that sine 30 is 1 by 2. Sine 45 we found out, we derived it as 1 by root 2. Sine 60 is root 3 by 2. Sine 90 is 1. So sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. And sine 90 is 1. This row has to be memorized by you. Now I'm going to share the technique with which we can fill this table. ठीक है, कोई भी क्वेश्चन स्टैंडर्ड एंगल्स का आया, ट्रिग्नोमेट्रिक रेशियोज ऑफ स्टैंडर्ड एंगल्स का कोई भी क्वेश्चन आया, तो ये टेबल तुम्हारे सामने रेडी होना चाहिए एज अ रेफरेंस. इट शुड बी इन फ्रंट ऑफ यू. यू डोंट हैव टू मेमोराइज करे साइन 45 क्या था, tan 60 क्या है. You don't have to memorize all that. You need to have the table ready in front of you. So एग्ज़ाम में जब तुम क्वेश्चन सॉल्व करोगे तो उसके रफ पेज पे, आंसर शीट के रफ पेज के बैक साइड में तुम्हें ये टेबल बना के रेडी रख देना है. फिर रेफरेंस के लिए तुम बार बार उसको देख लो टेबल को और वैल्यूज पुट कर लो, और प्रैक्टिस करने के बाद ये सारी वैल्यू तुम्हें मेमोराइज हो जाएगी. बट अगर नहीं होती है तो टेबल फिर भी रेडी होना चाहिए. ठीक है. सो कॉस, अब कॉस के रो को फिल करने के लिए एक ही टेक्निक याद रखनी है, दैट यू हैव टू पुट ऑल द वैल्यूज ऑफ साइन इन द रो ऑफ कॉस बट इन रिवर्स ऑर्डर. तो कॉस 0 1 हो जाएगा, फिर आएगा रूट 3 बाई 2, फिर आएगा 1 बाई रूट 2, फिर आएगा 1 बाई 2, फिर आएगा 0. अब आया टैन. तो टैन क्या होता है? तो बेसिकली tan theta is sin theta upon cos theta, right? Tan theta is sin theta upon cos theta. So sin देखो भी tan 0 मुझे निकालना है, तो sin theta upon cos theta, sin 0 upon cos 0, 0 upon 1, 0 upon 1 is 0. Tan 30 degree, 1 by 2 upon root 3 by 2. So 1 by 2 upon root 3 by 2 is 1 by root 3. सीधा डिवाइड करना है and you get the value of tan 30. Tan 45, 1 by root 2 divided by 1 by root 2, 1. Sin theta upon cos theta, that's what I'm doing, okay? Tan 60, root 3 by 2 upon 1 by 2, root 3. Tan 90, 1 by 0. See, anything divided by 0 is not defined. So this is not defined. You can just put a dash over here. Sometimes people, they use infinity sign also, because it's undefined, not defined. Tan 90 is not defined. ओके, tan 90 की कोई वैल्यू नहीं होती है या इनफाइनाइट वैल्यू होती है, बिकॉज 1 by 0 इज नॉट डिफाइंड. कॉट 0। अच्छा, अभी कॉट में क्या करना है, जो टैन की वैल्यूज हमने डाली उसको रिवर्स ऑर्डर में लिख देना है। तो नॉट डिफाइंड, √3, 1, 1/√3 एंड 0, कॉट भर गया। सेक, सेक क्या होता है, सेक इज अ रेसिप्रोकल ऑफ कॉस, तो कॉस की जो भी वैल्यू उसको रेसिप्रोकल करके लिखनी है। तो 1, 2/√3, √2, 2 एंड 0 का रेसिप्रोकल होता है 1/0 विच इज नॉट डिफाइंड। और कोसेक, सेक का रिवर्स ऑर्डर है, नॉट डिफाइंड, 2, √2, 2/√3 एंड 1। तो कितना इजी है ये टेबल बनाना, इसको याद करना, ठीक है, इसकी वैल्यूज फिल करना कितना इजी है। बट ये टेक्निक की ज़रूरत है, जो टेक्स्ट बुक में नहीं बताएंगे टेक्निक, टेक्स्ट बुक में तो तुम्हें इन्फॉर्मेशन दे दी है, अब तुम्हारे जैसे भी तरीका है उससे याद करो। सो दिस इज इम्पोर्टेंट। टेबल बना लो अभी वीडियो पॉज करके, ठीक है, फिर हम आगे बढ़ते हैं। Okay, so if you're done, if you're comfortable with the trigonometric ratios, the values of trigonometric ratios of standard angles and the table, let's move ahead. Remember, this table is a reference for you, so keep it in front of you while we are solving the examples. You can keep this part in front of you of your textbook while we are doing the solved examples, so that you know that which values I'm putting, right? Okay, let me just zoom in. Okay, so this is the table which we draw, and there are some observations which are given here. It can be seen from the table that as the angle increases from 0 to 90, the value of sine increases from 0 to 1, the value of cos decreases from 1 to 0, and the value of tan increases from 0 to infinity, and so on. So that's one pattern they have mentioned. If x and y both are equal to 45 degree, or x plus y is equal to 90, then sin x is equal to cos y. So that means if x and y both are 45, or both the sum of both of them is 90, that means they are, you can say, complementary angles, then sin x and cos y will be equal, tan x and cot y will be equal, and sec x and cosec y will be equal. For example, sin 45 is equal to cos 45, which is 1/√2. Sin 30 and cos 60 will be equal, which is equal to 1/2. Here x plus y is 90, and here x plus y is 90, and x and y both are equal to 45. Whatever the measure of angle A, B, this is very important because these are square relations. Whatever the measure of angle A, B, sin square A plus cos square A is always equal to 1. This is the first square relation. I think I mentioned this in the previous video for the previous chapter 22. This time they are re-emphasizing it, and they are proving it with one angle A. That sin square A plus cos square A is 1, sec square A minus tan square A is 1, and cosec square A minus cot square A is 1. So you must write these square relations now. We are going to use them in this chapter. For angle A equal to 30 degree, sin square A plus cos square A is sin square 30 plus cos square 30, which is 1/2 the whole square plus √3/2 the whole square, which is 1/4 plus 3/4, which is 4/4, which is 1. Sec square A minus tan square A, if you calculate, you will get 1, and cosec square A minus cot square A is also 1. But always remember this very important thing. Sine of angle A plus B is not equal to sine A plus sine B. Cos of angle A plus B is not equal to cos A plus cos B. Tan of angle A plus B is not equal to tan A plus tan B, and sine of angle A minus B is not equal to sine A minus sine B. So the sine cannot be distributed, sine or cos or tan cannot be distributed over addition and subtraction. Okay, so this is very, very important. So now we have taken the introduction to this chapter, we have drawn the table, we know what is this chapter all about. So I think we are ready to start with this chapter, with the solved examples of this chapter. Let's begin. Okay, let's begin with the first question. Okay, so we have to evaluate. Evaluate means find the value. Number one, sine square 30. Sine square 30 minus 2 cos cube 60 plus 3 tan raised to 4 45. Okay, now sine 30 is 1 by 2. Remember sine square 30, I have I think told earlier also that sine square theta is equal to sine theta the whole square, and it is not equal to sine theta square. एंगल को स्क्वायर नहीं करना है, हमें साइन थीटा को पूरे को स्क्वायर करना है. ठीक है, प्लीज रिमेंबर दिस. ये सारे ट्रिग्नोमेट्रिक रेशियोज के लिए एप्लीकेबल है. सो साइन स्क्वायर 30 इज इक्वल टू साइन 30 द होल स्क्वायर minus 2 into cos of 60 the whole cube plus 3 into tan of 45 the whole raised to 4. Sin 30 is 1 by 2. So we have 1 by 2 the whole square minus 2 multiplied by cos 60. See, cos 60 is also 1 by 2. You can check in your table. Keep your table, trigonometrical table, which we just drew, open in front of you. So cos 60 is also 1 by 2, the whole cube, plus 3 times tan 45 the whole raised to 4. That is 1 raised to 4. Tan 45 is 1. So this is 1 by 4 minus 2 into 1 by 8 plus 3 into 1, which is 3. So this will be 1 by 4. So 1 by 4 minus 1 by 4 plus 3. This gets cut and we get 3 as the answer, which is absolutely correct. Did you understand? So we just have to substitute the values of the standard trigonometrical ratios of the standard angles into the equation and evaluate. So most of the questions of this chapter, this particular topic, is based on evaluation. Just substituting the values and simplifying and getting the answer. Isn't that easy? Let's go to the second question. Let me make some space. Okay, number 2. Cos 0 plus sin 45 plus sin 30 multiplied by sin 90 minus cos 45 plus cos 60. Cos 0 is 1. Sin 45 is 1 by root 2 and sin 30 is 1 by 2 multiplied by sin 90 is 1 minus cos 45 is 1 by root 2 and cos 60 is 1 by 2. Okay, let's take LCM over here. The LCM will be 2 root 2. So this will become 2 root 2 plus this will be 2 plus this will be root 2 the whole upon 2 root 2. Okay, so this is 2 root 2 minus 2 plus root 2 the whole upon 2 root 2. Okay, let's simplify this further. We have 2 root 2 plus root 2. 2 root 2 plus root 2 is 3 root 2 plus 2 by 2 root 2. 2 root 2 plus root 2 is 3 root 2 minus 2 upon 2 root 2. So 3 root 2 plus 2 bracket 3 root 2 minus 2 the whole upon 2 root 2. So 3 root 2 the whole square minus 2 the whole square, the whole upon 2 root 2. So 3 root 2 the whole square, that is 3 root 2 square is 18, minus 2 square is 4 upon 2 root 2. Hey. There is one mistake. So there is multiplication over here. So this 2 root 2 will become square. 2 root 2 square. And 2 root 2 square is 8. Two root 2 square is 8. Okay, so 18 minus 4. 18 minus 4 is 14 by 8. So 2 4s are 2 7s are. So 1 3 by 4. 1 3 by 4 is the mixed fraction answer of this second expression. So we have evaluated, just put the value and evaluate it. Right, simple. Let's go to the next question. This is also evaluate. Sine 30 minus sine 90 plus 2 cos 0 the whole upon that tan 30 multiplied by tan 60. Sine 30 is 1 by 2 minus sine 90 is 1 plus 2 cos 0. Cos 0 is also 1. Tan 30 is 1 by root 3 times tan 60, which is root 3. If you have your table in front of you, you will be surprised that I've already memorized all the trigonometrical values of the standard trigonometrical ratios. Yeah, so that's how it should be with you also, but that will require a lot of practice and some time. Okay, so root 3 gets cut. So here we have 1 by 2 minus 1 plus 2 upon 1, which is 1 by 2 minus 1 plus 2 is plus 1. 1 plus 1 by 2 is 1 by 2 or 3 by 2. So simple 4 steps you get the answer. You just have to substitute the values. Okay, this is interesting. So these kind of questions are little out of the way, but they are interesting. Let's do it. If angle A is 60, we have to verify that number 1, sine square A plus cos square A is 1. So LHS is sine square A plus cos square A, which is sine square 60 plus cos square 60. Okay, what is sine 60? Root 3 by 2, but we have square, so whole square. What is cos 60? 1 by 2, the whole square. So that is 3 by 4 plus 1 by 4, which is 4 by 4, which is 1. Number 2. LHS. We have to prove that sec square A minus tan square A is 1. Sec square A minus tan square A. So sec square 60 minus tan square 60. Now what is sec 60? Now see, I'm just going to use the technique to find sec 60. I'm not going to look at the table because I know the technique. Sec 60 is the reciprocal of cos 60, and cos 60 is 1 by 2. So reciprocal of 1 by 2 is 2, right? So sec 60 is 2. So 2 square minus tan 60. Tan 60 is root 3 square. So 2 square is 4 minus root 3 square is 3. So 4 minus 3 is 1. Simple. So we verified that LHS is equal to RHS in both the cases. Easy. Let's go to the next question. Interesting question again. If x is equal to 15 degree, evaluate 8 sine 2x cos 4x sine 6x. So 8 times sine 2 into 15 times cos 4 into 15 times sine 6 into 15. So 8 times sine 30 times cos 60 times sine 90. That is 8 times. Sine 30 is 1 by 2. Sine 30 is 1 by 2 times cos 60 is root 3. I'm sorry for that. Cos 60 is also 1 by 2 times sine 90 is 1. So 8 by 4, which is 2. Very easy. Let's go to the next question. So as you can see, the questions are not very lengthy in this, just like the previous question. There are many questions, but not very lengthy. So A is 60 degree and B is 30 degree. We have to prove that sine of A minus B is sine A cos B minus cos A sine B. Now this is one identity of compound angles which you are going to use in class 11th and 12th, which you have to prove here. So very interesting. So let's prove LHS first. LHS is sine of A minus B, that is sine of 60 minus 30, which is sine of 30 degree, which is 1 by 2. What is your RHS? RHS is sine A cos B minus cos A sine B. Sine 60 times cos 30 minus cos 60 times sine 30, right? B is 30. Okay, sine 60 is root 3 by 2. Cos 30 is root 3 by 2 minus cos 60 is 1 by 2 times sine 30 is also 1 by 2. So this is root 3 times root 3 is 3, 2 by 2, 2 times 2 is 4 minus 1 by 4, 3 minus 1 by 4, 2 by 4, which is 1 by 2. So your LHS becomes, so your RHS becomes 1 by 2. LHS was already 1 by 2 and we have proved this identity. Let's go to the next question. This is also one of the formula which you are using, which you will use in class 11th and 12th. So A is equal to 30 degree. You have to prove that LHS, which is cos 3A, which is equal to cos of 3 times 30, which is cos of 90, which is 0, is equal to RHS 4 cos cube A minus 3 cos A. So 4 times cos cube A. See, cos of angle A is 30 degree. So cos 30 degree the whole cube minus 3 cos A. 3 times cos of 30 degree. So 4 times, okay, so this will be cos 30, that is root 3 by 2 the whole cube minus 3 times root 3 by 2. Okay, so this will become 4 times 3 root 3 by 8 minus 3 root 3 by 2. So 3 root 3 by 2 minus 3 root 3 by 2, which is 0. So LHS is equal to RHS. You just have to substitute the values, man. All the questions are similar. Let's go to the next question. Okay, next question is find A if sine 2A is 1, 2 cos 3A is 1, and sec of A minus 2 and tan 3A minus 1 is 0. Okay, so you have to find the value. Hey, there is no fourth option over here and they've given the fourth answer. So that means it is not, I'll just take it when I solve it. So the first one is sine 2A is equal to 1. So if I want to solve this, see how to solve this is solving trigonometrical equations. This is known as trigonometrical equations and we have to find the value of A. Okay. So I will write it first as sine 2A is equal to sine 90 because sine 90 is 1, right? So in the place of 1 I wrote sine 90. Now I can remove sine from both the sides. So therefore 2A is equal to 90 and therefore A is equal to 90 by 2. So A is equal to 45 degrees. Number 2, 2 cos 3A is equal to 1. So cos 3A is equal to 1 by 2. So cos 3A is equal to cos 60 because cos 60 is 1 by 2, right? So we can remove cos from both the sides and we get 3A as 60. So A is equal to 60 by 3. And since A is 60 by 3, so A is equal to 20 degrees. Question number 3. Sec A minus 2 bracket tan 3A minus 1 is equal to 0. Find the value of A. Now see, this is the product of two brackets. So this is kind of factorization of a quadratic equation, kind of a problem. So the multiplication of two brackets if it gives us 0, or multiplication of two terms if it gives us 0, then one of them must be 0. Product of two terms is 0 only when one of the two terms is 0. So we don't know which is 0. So this is possible only if sec A minus 2 is 0 or tan of 3A minus 1 is 0. So sec A is equal to 2 or tan 3A is equal to 1. Sec A is equal to 2 or tan 3A is equal to 1. Okay. Now sec A is 2 when 1 upon cos A is 2. Right? Sec A is 2 means sec A means 1 upon cos A. And the 1 upon cos A is 2 means cos A is 1 by 2. So A must be 60 degree. So sec of 60 is 2. So we can write that sec A is equal to sec 60 and therefore A is equal to 60 degree. Or tan 3A is 1. So tan 3A, sorry, is equal to tan 45 because tan 45 is 1. So removing tan from both the sides, we get 3A is equal to 45 and A is equal to 45 by 3, which is 15 degrees. So A is 60 degree or 15 degrees. That's two answers we are getting, double answer, 60 or 15. Okay, here there is only one answer given, but actually the answers are two. Okay, and the fourth question is not given here. Let's check it out in the textbook. So as you can see, we are on part C already. Yeah, we are on the 7th question, so we are on the third part. See how small the parts are and how simple the questions are. Yes, so we are getting two answer here, 60 and 15. And what is the fourth question? Hey, there is no fourth question. But why then there is fourth answer? Okay, so they have written third and fourth answers. The third answer says third and fourth. That's why there are three answers. Okay, no problem. 60 and 15. 60 or 15 actually. Let's look at the next question. From the adjoining figure, find tan x, x cos x, and use sin x to find y. Wow. Okay, so we cannot find y by Pythagoras theorem because they have clearly mentioned use sin x to find y. That's not a problem. So let's first find tan x. Tan x is opposite upon adjacent. Opposite of x is BC and adjacent is AB. BC is root 3 and AB is 1. So tan x is equal to root 3. Root 3 by 1 or root 3. So we found tan x. So what is x? This is the first answer. So tan x is equal to tan of 60 because root 3 is tan 60. So therefore x is 60 degree. So this is the second answer. Cos x, the third answer. Cos of x, x is 60, so cos 60, which is 1 by 2. We got the third answer. And use sin x to find y. Okay. Sin x is opposite upon hypotenuse. Okay. So opposite is BC and hypotenuse is AC. See, x is 60 degrees, so we can write sin 60 is equal to BC upon AC, which is root 3 upon y, and sin 60 is root 3 by 2 is equal to root 3 by y, and therefore y is equal to 2. All the answers are correct. Easy. Let's go to the next question. So, do you now agree with me that this chapter is smaller? The previous chapter 22 was lengthier. It was quite lengthy. This is very small chapter. Question number 9. If 4 sine square x minus 3 is 0, 4 sine square x minus 3 is 0 and x is an acute angle, find sin x and x, right? So 4 sine square x is equal to 3, or sine square x is equal to 3 by 4. So sin x will be root of 3 by 4. So sin x will be root 3 by 2. So sin x can also be written as sin 60. So x is equal to root 3, x is equal to 60 degree. I'm sorry for that. Removing sign from both the side, we get x is equal to 60 degree. This is your second answer and this is your first answer. So 5 steps and you get your answers. Very easy. Okay, here comes some complicated questions. So question number 10, 11, 12, 13, 14. Yeah. So these 4-5 questions are little lengthier as you compare with the whole chapter. This is the only lengthy part. Okay. Up to here, the questions were quite simple and easy. But now comes the little lengthier part. Please pay attention. Number 1. Find the magnitude of angle A. So these are trigonometric equations which we have to solve. Please pay attention. 4 sine A times sine of 2A plus 1 minus 2 sine 2A is equal to 2 sine A. Okay, so this will become 4 sine A times sine 2a, okay, minus 2 sine 2a minus 2 sine a is equal to 0. So what can be done now? Can we take out common? Hey, there is plus 1 as well, which I forgot to write. I'm sorry for that. Yes, so plus 1, I'll write it over here. Great. Now I'm going to take common from these two terms and these two terms. So what I'm trying to do is so this is a trigonometric equation from which I have to find the value of angle A, and the right way of doing that I feel is factorization. So what I'm going to do is I'm grouping and taking out common. That method of factorization which we have learned in chapter number 5, we are using it over here. So factorization is not only limited to factorization chapter. It finds its application in many other chapters in mathematics. This is one of the example. So what is common out of these two terms? So 2 is common and sine 2a is common. And if you take out 2 sine 2a, you will be left with 2 sine a inside, because sine 2a comes outside. 2 comes outside as a factor, so 2 sine a is remaining inside, minus 1. Here there is nothing common, so minus 1 comes out common and you get 2 sine a minus 1. So that was very easy to factorize. Now from these two terms, what is common? 2 sine a minus 1 is common, and 2 sine 2a minus 1 is left inside. So now we have factorized this whole equation. So what we are going to do is, since the product of these two brackets is 0, either of them should be 0. So 2 sine a minus 1 is 0, or 2 sine 2a minus 1 is 0. So 2 sine a is equal to 1, or 2 sine 2a is equal to 1. So sine a is equal to 1 by 2, or 2 sine, I'm sorry, I have to take 2 to the other side, I forgot. Sine 2a is equal to 1 by 2, right? So sine a is equal to sine 30, or sine 2a is equal to sine 30. So a is equal to 30 degree, or 2a is equal to 30 degree. So a is equal to 30 degree, or a is equal to 30 by 2, that is 15 degrees. Okay, so a is 30 or 15 degrees. So this is only the first part of question number 10. So you can imagine that solving trigonometric equations is not very, very simple like the questions which we did earlier. Trigonometric equations are little lengthier. So that's question number 10 to 14. The 5 questions are going to be a bit lengthy. That's my warning to all of you, that please beware of these questions. Okay, let me make it a little bit smaller and move it to the other side. Let's try the next question. Sub question 2. 2 sine square a minus 3 sine a. 2 sine square a minus 3 sine a plus 1 is equal to 0. See, I'm going to do one very easy thing which will help you to solve this question. Let sine a equals to x. Let sine a equals x. So therefore 2x square minus 3x plus 1 is 0. That means 2 ones are 2. That's the factor of 2. And I want minus 3. So I'll put minus 2 and minus 1 over here. So minus 2 times minus 1 is plus 2. Minus 2 minus 1 is minus 3. 2x square minus 2x minus x plus 1 is 0. So 2x comes out common. X minus 1 minus 1 comes out common. X minus 1 is 0. So 2x minus 1, x minus 1 is 0. Therefore 2x minus 1 is 0 or x minus 1 is 0. Therefore 2x is equal to 1 or x is equal to 1. So x is equal to 1 by 2 or x is equal to 1. So what is x? X is sine A. Let's solve this further. Sine A, therefore sine A is equal to 1 by 2 or sine A is equal to 1. So if sine A is 1 by 2, if sine A is 1 by 2, A is 30 degree, and if sine A is 1, A will be 90 degree. So A is 30 or A is 90. That's the solution of this trigonometrical equation. So as you can see here, we use splitting the middle term. In the previous question, we used the method of factorization, which was grouping and taking out common. Here we used splitting the middle term. That is the whole idea, that in this chapter, in this part of this chapter, we have to factorize trigonometrical equations and we have to find the value of the missing angle. Let's do the third question. Third question is 3 cot square of x minus 5 is equal to 1. So I'm going to write it as cot square x minus 5 is equal to 1 by 3, square rooting both the sides. Cot of x minus 5 is equal to 1 by root 3. So cot of x minus 5 is equal to, now see, cot 60 is 1 by root 3. So I can simply write it as cot 60. And removing cot from both the sides, x minus 5 is equal to 60. So x is equal to 60 plus 5. So x is equal to 65. That's the third answer. This was comparatively quite simple. All right, the next question, the fourth question I'm going to solve over here. Sine square 2x, sine square 2x plus sine square 60 is equal to 1. Okay. Sine square 2x plus sine 60. Now sine 60 is root 3 by 2. The whole square. So sine square 2x plus 3 by 4 is equal to 1. So sine square 2x is equal to 1 minus 3 by 4. So sine square 2x is equal to 4 minus 3 by 4, which is 1 by 4. Okay, so sine square 2x is 1 by 4. So sine 2x, square rooting both the side, we get 1 by 2. So sine 2x is equal to sine 30. So 2x, removing sine from both the side, 2x is equal to 30, and therefore x is equal to 15 degrees. X is 15 degrees. That's your answer of the fourth part. So third and fourth part were quite simple. First and second part, as you saw, were lengthy, and we saw the use of factorization in solving trigonometrical equations. Let's see what is question number 11. It has just one part, thank God. So it's not going to be very lengthy. Find the acute angles A and B. If sine of A plus B, sine of A plus B is equal to cos of A minus B, which is equal to root 3 by 2. Okay, this is easy. Sine of A plus B is root 3 by 2. That means A plus B is must be 60. Should be A plus B must be 60, right? Because sine 60 is root 3 by 2. Also, cos A minus B is root 3 by 2. So cos 30 degree is root 3 by 2. And A minus B should be equal to 30 degree. So this is equation 1 and this is equation 2. We have to find A and B, adding 1 and 2. Adding equations 1 and 2, we get A plus B as 60 plus A minus B as 30. We get 2A is equal to 90 and A is equal to 90 by 2, which is 45. Okay, so we got A as 45. Now, substituting the value of A, which is 45, in equation 1. So A plus B is equal to 60. So 45 plus B is equal to 60. So B is equal to 60 minus 45, which is 15. So B is 15 degrees, A is 45 degrees, 45 and 15. That's your answer of A and B. Easy. Let's go to the next question. This is also similar. Tan of A plus B is root 3. Tan of A plus B is equal to root 3. And tan of A minus B is equal to 1. Find A and B. So this question has to be solved by you. This question has to be solved by you. What you can do is, I'll just give you a hint. Tan 60 is equal to root 3. Therefore, A plus B is equal to root 3. And tan 45 is 1. So A minus B. Hey, sorry. I just made a huge mistake. Tan A plus B is root 3 and tan 60 is root 3. So A plus B is 60. And A minus B is 45. So this is equation 1. This is equation 2. Solve the both the equations and you get the value of A and B. But I doubt whether A minus B, I doubt whether, can A minus B be 45 degree? That's a little strange. Or maybe the answer given over here is little strange. A and B, 45 and 15. There can be another answer as well. There can be. Let's solve it, because the answer given over here I don't understand, because A minus B can never be 45 if A is 45, right? So I don't agree with this answer. Let me solve it. So I'm going to add equation 1 and 2. A plus B is 60 and A minus B is 45. So 2A is equal to 105. That is really strange. A plus B is root 3 and A minus B is 1. So A is equal to 105 by 2. Okay. If I substitute the value of A in any of the equation, let's say equation 1. So 105 by 2 plus B is 60. So B is 60 minus 105 by 2. So that is 120 minus 105, which is 15 by 2. So I'm getting some weird answer over here, A and B. Let me check the question. Tan A plus B is root 3. So A plus B is 60. That's perfect. Tan A minus B is 1. So A minus B is 45. Okay, let's check the answer. I'm not happy with the answer here. This is question number 12, I think. Yes. Okay, so tan. Oh, root 3 tan A minus B is 1. See? There is a mistake in the question. Root 3 times tan of A minus B. And there is root 3 over here. Oh, but then there is, okay. So the question is, there is a mistake in the question. Let me correct it. So this I'm going to correct, and I'm going to write it again over here. Root 3 times tan of A minus B is 1. So tan of A minus B is 1 by root 3. Okay, so here you will get 1 by root 3. So tan of 30 is 1 by root 3. So there are certain changes here. See, there is mistaken question and we have to do everything again. So tan of 30 is 1 by root 3. So A minus B is not 45, it is 30. A plus B 60. Okay, 45. Yes, I think now it is correct. So this is, sorry, 30, not 45, 30. A minus B is 30. Yeah, so on solving these two equations, you get 2A is 90 and A is 45. So B has to be 15. Right, so good, we checked the question and found the answer, found the mistake in the question. Okay, let's do this, the second last question of the chapter. If root 3 tan 2 is equal to 3, I really don't understand this question because there is something wrong with the question. Okay, let's see the original question number 13 and solve it. Okay, so there is theta which was not given. If root 3 tan 2 theta is 3, root 3, wait, I'm going to solve it here itself, okay? So please don't feel bad. Oh, okay, root 3 times tan 2 theta is equal to 3. So tan 2 theta is equal to 3 by root 3, which is tan 2 theta is equal to root 3. That is 2 theta is equal to 60 degrees and theta is equal to 30 degrees. So we got the value of theta. So theta is between 0 and 90. Yes, of course. Find the value of 3 root 3 cos theta plus 2 sine theta minus 6 tan square theta. 3 root 3 times cos 30 degree plus 2 sine 30 degree minus 6 times tan square 30 degree. Cos 30 is cos 30 is root 3 by 2. 2 times sine 30 is 1 by 2. 2 times sine 30 is 1 by 2. Minus 6 times tan square 30 is 1 by root 3 the whole square. Okay, so we just have to evaluate this. Let's make some space. Okay, let's do the evaluation over here. So we have 3 root 3 times root 3. So that is 3 3s are 9 by 2. This 2 will get cut. We get plus 1 minus 6 times 9 by 2 plus 1 minus 6 by 3, which is 2. So 9 by 2 minus 1. So 9 minus 2 by 2, which is 9 minus 2 is 7, 7 by 2. Okay, so that's the evaluation. Okay, 7 by 2 can be written as 3 1 by 2. Let's check the answer. Yes, it is 3 1 by 2. Okay, so that was the second last question. Let's go to the final question of the chapter, 14th question. Okay, solve for theta, where theta is between 0 and 90 degree. Number 1, first equation. Sine square theta minus half sine theta is equal to 0. So this is also like trigonometrical equations, but with theta. So we have to find theta. So sine square theta is equal to half sine theta. 2 will go that side. So we have 2 sine square theta is equal to sine theta. So what we can do is we can bring sine theta at this side and we can write it as 2 sine square theta upon sine theta is equal to 1. So sine theta and sine square theta square will get cut. So 2 sine theta is equal to 1. So sine theta is equal to 1 by 2. So sine theta is equal to sine 30 degree, right? And theta is equal to 30 degree. So that's the first trigonometrical equation solved for you. Very easy. It was not very difficult. This was like linear equation in one variable. Not even, there is no factorization required. Yeah, if you want, you can factorize, but it's not required. Number 2, 2 sine square theta minus 2 cos theta is equal to 1 by 2. Now this is going to be a little challenging because we have sine and cos in one trigonometric equation. So if you remember, I've given you square relation. Sine square theta plus cos square theta is 1. So sine square theta is equal to 1 minus cos square theta. So in place of sine square theta, I'm going to write 1 minus cos square theta. So 2 bracket, in place of sine square theta, I have 1 minus cos square theta minus 2 cos theta is equal to 1 by 2. Okay, so let's do one thing. Okay, so let's take this 2 to the other side. So we have 2 the whole bracket, 2 times 1 minus cos square theta, and here we have minus 2 cos theta. is equal to 1. Okay, so if we multiply 2 throughout, we get 4 bracket 1 minus cos square theta minus 4 cos theta is equal to 1. And if we simplify this, open this, we get 4 minus 4 cos square theta minus 4 cos theta minus 1 is equal to 0. So this will be minus 4 cos square theta minus 4 cos theta plus 3 is equal to 0. Now if we change the signs, we get 4 cos square theta plus 4 cos theta minus 3 is equal to 0. Now let's try splitting the middle term over here. So let cos theta is equal to x. So we have 4x square plus 4x minus 3 is equal to 0. So minus 3 times 4 is minus 12. Minus 12 split into its factors to get 4. So 6 2s are 12. Yeah, 6 and 2 can give us 4. So plus 6 minus 2. Plus 6 minus 2 is plus 4, and plus 6 multiplied by minus 2 is minus 12. So we can write it as 4x square plus 6x minus 2x minus 3 is equal to 0. So 4x bracket 2x, hey, we can't take out 4x common. We can just take out 2x common. So 2x plus 3 minus 1, 2x plus 3. So 2x plus 3 bracket 2x minus 1 is equal to 0. So 2x plus 3 is equal to 0, or 2x minus 1 is equal to 0. So 2x is equal to minus 3, or 2x is equal to 1. So x is equal to minus 3 by 2, or x is equal to 1 by 2. So x is cos theta. So cos theta is minus 3 by 2, or cos theta is equal to 1 by 2. Now in the question they have already mentioned this very clearly, that theta is between 0 and 90, and we know that in between 0 and 90, if theta lies between 0 and 90, it can never be negative. So we will reject this value of cos theta and we will accept this value, right? So cos theta is equal to cos 60 and theta is equal to 60 degree will be the solution of this second question. Yeah, so this was little long because there is factorization involved and little tricky. Yeah, so that was question number 2. We have one more question. Tan square theta plus 3 is equal to 3 sec theta. Tan square theta plus 3 is equal to 3 sec theta. Tan square theta plus 3 is equal to 3 sec theta. Okay, I'm going to solve this question with one of the square relation, that is 1 plus tan square theta. 1 plus tan square theta is equal to sec square theta. Okay, so in the place of tan square theta, I'm going to write sec square theta minus 1. Sec square theta minus 1. So this will be sec square theta minus 1 plus 3 is equal to 3 sec theta. Now let's bring everything on the LHS. So sec square theta minus 3 sec theta, 3 minus 1 is plus 2 is equal to 0. So let sec theta is equal to x. So x square minus 3x plus 2 is equal to 0. Let's do splitting the middle term. Plus 2. The splitting of plus 2 will be 2 ones are 2. minus 2 minus 1. Minus 2 multiplied by minus 1 is plus 2, and minus 2 minus 1 is minus 3. So x square minus 2x minus x plus 2 is equal to 0. X bracket x minus 2 minus 1 bracket x minus 2 is equal to 0. So x minus 1 bracket x minus 2 is equal to 0. Therefore, x minus 1 is 0 or x minus 2 is 0. Therefore, x is 1 or x is 2. So x is nothing but sec theta. X is sec theta. So sec theta is equal to 1 or sec theta is equal to 2. Now we know that sec theta can never attain a value of 1. So we will reject this sec theta is equal to 1 option. We know that sec 60 is equal to 2. Therefore, theta is equal to 60 degree. So that's the answer. So here we use this very important square relation, which I want to emphasize again. I have talked about square relation in between this chapter at different instances. So you need to remember all the square relations and use them whenever required, like this question. Okay, so we got all the answers. Yeah, so that was the final question of the chapter. So this chapter is over now. Chapter number 23. So there are two more chapters to go in the trigonometric unit. They are not very lengthy, not very long. So we are going to finish them very soon. Okay, so see you later. See you in the next class. Bye-bye.